All right, we are studying the reviewing process, and here we just want to list the important concept and possible questions related to each of this concept. And we should note that after test two, we went through a lot of topics, and some of them require quite a bit of calculation and understanding, and we really need to pay attention to them. All right, so we started with the double integral setup, right? So topic one, double integral. And particularly, we need to do a couple of things. Set up double integral, the iterated integral. In the Cartesian coordinates and in the polar coordinates. In Cartesian. Or in the polar coordinates. This is a Cartesian xy plane, and this is in or in r theta plane. And in the r theta plane, we really have to pay attention to this the differential of the area, and because in the Cartesian coordinates xy plane, note differential of the area in the Cartesian coordinate could be dx dy or dy dx, but in the polar coordinates, we have r times dr d theta or r times d theta dr. Okay, and the tricky parts in identifying the or setting up those double integral is to identify the boundary and represent the domain in the proper coordinate and by using proper curves. So essentially the lower and upper limit for each of those integral in your double or later triple integral is the key in solving this problem. And the typical question we can deal with is, for example, change the order of the integration. For example, I think we discussed this in class. 0, 4, and this is square root of x2. I can't remember exactly, but maybe this is the one. Okay, evaluate by change the order of integration. We discussed this in class. You can review this. Essentially, this is x equals 0 to 4, and y is equal to square root of x to 2, and you have to identify what is the region, where the domain of integration, and identify either type 1 or type 2 region, and then switch the treatment of the either type 1 to type 2. Okay, and also in the application of the double integral, we need to remember the compute the center of mass. Okay, so in computing the center of mass, we need to compute either the first the total mass, and which is m equals to double integral of rho xy dx dy. Well, depending on how you arrange it, you could compute it in the polar coordinates, and you also have to compute the moment mx and my, right? And also similar related to this, we also need to know how do we compute the probability by using the double integral with the probability density function rho of xy with rho the integral of rho over the domain D is 1 and rho of xy is non-negative. All right, and the probability for the joint distribution, a joint variable x and y will be depending on how where you want to evaluate the probability that those x and y variable actually occurred. All right, and what else? I think then it was discussed in the later part after the triple integral, but there is also this so-called the change of variable. We put it here because we only check the change of variable with the transformation. And the so-called the Jacobian determinant, if you remember. All right, so the if we have the original double integral set it up, we can do the change of variable t by introducing two variables, u and v. All right, and then we can evaluate this new integral is the absolute value of the Jacobian determinant in the UV plane. And here, this is absolute value of Jacobian determinant, and this x of UV, y of UV is so-called the inverse transformation or something that whatever you want to call. Okay, we discussed this, and you probably will you already worked on this in the quiz last week, and hopefully that you remember this. All right, so those are the main topics in the double integral. They are quite tricky, and sometimes they are quite tricky if you do not know how to work on them, and especially that if you have some difficulty in identifying those boundaries for the domain integration, and you probably need to practice a little bit more if you're not familiar with that. Oh, another type of question is set up the domain integration if the domain is actually bounded by a couple curves, right? And then later, for example, D is bounded by x equals 0, y equals 2, and y equals x squared, those three curves, how to set up the iterated integral for this double integral. This is the kind of question we could possibly see in the context of problems related to a double integral. All right, and then later, after we talk about the double integral, we are looking at the triple integral for sure, right? Topic 2, which is triple integral, and we need to set up the iterated integral for xyz plane in the Cartesian coordinates, volume E f of x, y, z dv, and here dv is dx, dy, dz, or dy, dz, dx, or with some other order, and you need to project. So key is project E onto axis plane. The key. Okay, we also need to set up the triple integral in the cylindrical coordinates. Remember, the key there is there's an actor R for the dv. Maybe we should, well, that's all right. So here, dv is equal to r dz dr dz. So we can compare it with the triple integral in the Cartesian or rectangle coordinates. And then also we need to have the triple integral in the spherical coordinate. All right, so there we need to set it up this with dv equals rho squared, rho squared sine phi d rho d phi d theta. So there's extra factor rho squared d rho squared sine phi here, and for the spherical coordinates, for the cylindrical coordinate, we have this extra r. Actually, this r and this is rho squared sine phi are indeed the absolute value of the Jacobian determinant after you do this change of variable from the Cartesian xyz to either this spherical or cylindrical coordinates. All right, so for those questions, you also need to compute the volume. Okay, compute the volume of solid or mass. Okay, and what else? Yeah, I think that's about it. And in many cases, especially in the spherical coordinates cases, things could be a little bit tricky. If you are not familiar with the spherical coordinates, I would urge you to go over the example again and look at those preparation question for each week's quiz. Okay, so after the triple integral, we start to talk about the vector field and line integral, right? So for the vector field, we need to know especially what is conservative vector field and how to check if vector field F is conservative and if F equals F1, F2, F3 is conservative. How to find scalar function v of xyz such that f is generated by taking the gradient of this v Okay, and then there are questions. Maybe I should list them. One, how to check. Second, and now the third, how to compute the curl and divergence of vector field F. Yeah, those are the concepts related to the vector field, and also we how to compute line integral of scalar function f of xy or f of x, y, z on curve given by c t which is in 2D or 3D. And here, remember the integral of f of xy, like f of xyz ds. What does this ds means? ds means the length of the velocity vector or tangent vector times dt, right? And then the second topic about the line integral is how to line integral of vector field on path curve CFT. Well, the integral is defined in this way, which is f dot the velocity of, well, here, this vector field f is evaluated only along the path C, and it is essentially computed in this way. All right, so there are quite a bit of the calculation, and there's the actual for parametric surface. S, which has the parameterization R of UV, and UV is from the domain D. How to find the normal vector of this surface S? The answer is the normal vector is the result of the cross products of the parameterization R of UV and the actual cross product of the partial derivative of this parameterization with respect to U and V separately. Okay, so those are the important key concepts, and we really have to go over those and then practice according to the each of the listed items, and we have to deal with this last test, and there are quite a bit of understanding in the calculation you need to go over and get it prepared. Okay, so if you have questions, you're encouraged to come to the office hour and we can discuss. And please remember to go over the quiz question and the quiz, especially the quiz review question and the homeworks, and it also class examples. And just redo every question with all the details so that you're prepared. Okay.